Well, there it is, folks. Lots and lots of snow in Zone 5, Wisconsin. Guten gardening, everybody. Well, it feels like winter's here today. We're getting gusts of wind 30 to 40 miles an hour. Of course, at this point, all of our garlic is nice and tucked away in bed, and almost everything out here just looks dead. You should notice there are still some things that are quite green. This is our kale, currently covered with some snow, colored greens, and our Brussels sprouts, which we're just about to harvest. In today's video, we're going to talk about why brassicas are so cold hardy. I've done some research, and this is what I've learned. Well, I started the video outside, but I had to go inside. It was just way too windy to record anything out there. But in today's video, I really want to focus in on why kale, cabbage, Brussels sprouts, the brassicas in general, thrive in chilly weather. And so I'm going to talk about some of those things that you might or might not know about brassicas. And the first thing I'm going to talk about is how they essentially make their own antifreeze. When temperatures start dropping outside, brassicas start pulling sugars into their cells. But it's not just sugar like we think of it, but natural plant sugars, amino acids, all of which act like antifreeze protectants. So these dissolved sugars lower the freezing point inside the plant, keep the cells from bursting, and as a bonus, they make the leaves and sprouts taste sweeter. That's why a lot of gardeners will tell you, this is definitely true for Brussels sprouts, but for kale and in general, wait for a frost, and then you're going to see the cold sweetens up those brassicas. Now, I've pulled up a lot of the dead plants out here, but if I looked around, you would see that a lot of my plants have died because most plants die when the insides of their cells freeze. The ice crystals expand, they rupture the cell walls, but based on my research, brassicas cheat the system because when they freeze, the ice doesn't form inside the cell walls, it forms between the cells. So this is a process called extracellular freezing. Extra means beyond, so beyond the cell freezing. And basically it keeps the important parts of each of the cells inside ice free. So the plant sacrifices the less important spaces so that the vital tissues stay intact. And I think this is really clever because it's one of the main reasons why they bounce back in the morning after a frost like nothing happened. And I'm going to show you an example of that right now. Now, in addition to making their own antifreeze and freezing in the right place so that they don't die, their cell membranes also stay flexible. So think of plant cells like tiny water balloons. For most plants, the balloons get brittle in the cold, they crack. You think of the cells breaking apart, then the plant is done. But brassicas change the fats in their cell membranes as temperatures drop. So they make their membranes more unsaturated, which keeps them flexible, kind of like a stretchy winter glove. So flexible membranes, and you can see my hand moving the leaves back and forth even in this cold, means the cells don't crack, which means plants can survive a deeper cold. And interestingly enough, and we've shown this from experience growing our kale all the way through December here in Zone 5, Wisconsin, and sometimes even overwintering the plant, that they stay active when other plants quit. Now, warm season plants like tomatoes, peppers, squash, they shut down when the soil cools off, but brassicas slow down, but their enzymes are still active at lower temperatures, so their metabolism still runs, and they can continue photosynthesizing even in the chilly winter. Again, you see all the green out here of these brassicas versus all the other dead plants. That's why in Zone 5 you can keep harvesting kale, collards, Brussels sprouts long after the rest of the garden is toast. Now, I've learned quite a bit from the research I did for this video, and this next point is one that I knew nothing about. So their cold hardening genes really kick in. Basically, brassicas have a built-in cold response system called the CBF Pathway. Now, you don't need to remember that name, but here's what it does. When the plant feels cold coming, it strengthens its cell walls, it increases its protective proteins, it boosts membrane flexibility, and ramps up those antifreeze sugars. And this is the real biological reason why hardening off works. When you expose seedlings to cool weather for a little bit, they literally activate these genes and toughen up for the season. And this is something that our brassicas do really well. And quite frankly, their structure protects them naturally. On top of all the cool tricks that happen internally with the plant, brassicas are just built for winter. They've got thick, waxy coatings on their leaves. You can see that coloration of that waxy coating when I show you the underside of these leaves. They have really dense layered structures. Think of our cabbage heads, for example. Most of these plants have compact forms that help protect their growing points, and kale leaves actually curl in ways that help shed frost. So these shapes reduce windburn, hold warmth, and keep cold air from reaching their most vulnerable tissues. I guess you could think of this almost like nature's winter coat. Now, to go back to something that I said earlier in this video, the cold actually does improve their flavor. So you remember those sugars that I talked about? Well, cold weather converts stored starches into sugars, and more sugars mean better frost resistance and better flavor. So if you've ever tasted a Brussels sprout harvested after a freeze, you know what I mean. One of my favorite harvests of Brussels sprouts happened after a massive snow, probably 5 or 6 years ago. They were sweeter, they were nuttier, and just dramatically less bitter than if harvested before the frost. So if you're growing brassicas, definitely don't rush those fall harvests. Yes, we've been harvesting all along in this process, but let the colder weather season them for you. Now, here's something else that you might or might not know. Brassicas didn't just magically become cold hardy. They actually developed all of their tricks to survive in the cold weather over time, over thousands of years in chilly, windy, coastal climates. In those conditions, only the toughest plants survived, and so humans selected the hardiest ones generation after generation. So today, the brassicas we plant are basically cold-adapted specialists designed for really good fall and winter growing. But they also still thrive in the summertime. So that's one of the essential reasons why, again, in our cool weather zones, we get such a long growing season with them. So those are some of the reasons why brassicas survive and thrive so well in the cold, in temperatures that other plants couldn't handle. I will tell you that some brassicas are better or more cold resistant than others. So the ones that are the champions of the cold weather, kale, collard greens, and Brussels sprouts, those are the three primary ones we have out right now. Cabbage, kohlrabi, and broccoli do pretty well. I've seen them handle temperatures as low as 20 to 25 degrees for brief periods. And then cauliflower, mustard greens, arugula, they'll handle the 25 to 28 degrees Fahrenheit. But really, again, kale, collards, and Brussels sprouts, man, I've seen them handle temperatures 10, 15 degrees and still come right back. So if you want late season or even winter production, brassicas should absolutely be a part of your garden plan, especially in colder climates like Zone 5, Wisconsin. Well, I really hope you enjoyed today's video and learned a lot about why these vegetables are so cold hardy, why our brassicas, especially in these cooler grow zones like Zone 5, Wisconsin, are so essential and last so much longer than so many of our other types of vegetables. Hey, if you enjoyed today's video, don't forget to give us a like, leave us a comment, remember to share and subscribe, and most importantly, remember, when you're with us, you are good to grow.